Hi all, my name is Pratima and I'm going to focus more on how the system was implemented. So the methodology that we followed to implement the system is as mentioned in this slide. We started by writing a parser code that parsed the Amazon dataset. So the slide over here shows a snapshot of the data structure as downloaded from the Snap network. As you can see over here, the Amazon dataset as downloaded from the Snap network does have a structure, but the structure was not consistent. As a result, we needed to write a parser code that will only extract the required attributes. So after completing the parser code with Amazon dataset, we proceeded by generating the customer and product profile for each of the customer and product that were there in the Amazon dataset. A product profile is a record that represents an important characteristics of a product such as product ID, product title, the average rating of the product, while a customer profile is a record that represents an important characteristics of a customer, which can be the customer ID, product he or she purchased, and the rating he or she gave to a product. After generating the customer and product profiles, we proceeded to the next phase of the implementation model, which was the clustering of the data points. The clustering of data points was the most important and the most rigorous phase throughout this project for two major important reasons. First, because we were running the clustering on our local machine, we had to ensure that our machine is able to handle all the data points generated from the clustering phase. Secondly, while clustering, we came across around 50 customers who had rated more than 10,000 products, going up to 20,000 in some cases. The data points generated from only these customers who had rated more than 10,000 products were so huge that the 500 GB of hard disks allocated just to run the clustering was insufficient. Also, since it is unlikely that a customer rates more than 10,000 products, these customers have been flagged as scammers and the data points generated from these flagged customers have been ignored. At this point, I find it important to inform the audience that we were able to successfully run the clustering phase only after removing the data points generated from these customers who were flagged as scammers. So, coming back to our main topic, which is how the clustering technique has been implemented in the system. So the clustering technique implemented in the system is that the data points are generated using the combinatorics approach, that is NC2. For example, if there are 5 customers, then the data points generated for these 5 customers is 5C2, which means that 10 data points will be generated for these 5 customers. Also, in order to be considered for clustering, the product pair must be rated by at least 2 common customers. For example, if P1 and P2 are any 2 products rated by a customer C as R1 and R2, then the data point generated for this customer is R1 and R2 for keys P1, P2. The output vector as generated from the clustering phase will have the following information as shown in the screenshot over here. So in this example, product B006086 and B001UODR are rated by 2 common customers and their ratings were 22 as rated by one customer and 24 as rated by another customer respectively. So after completing the clustering of data points, we proceeded to the next stage of our system, which was computing the correlation between 2 products. For this, all the data points generated from clustering stage is combined and grouped. The product pair for correlation computation for the system is considered only if both the products have been rated by at least 4 customers. The technique applied to compute the correlation between 2 products is mentioned in the slide over here. That is, for every item A and B, find all users who have rated both item A and B. Use the ratings to form item A vector and item B vector, and then compute the correlation between vector A and B. A screenshot of an output as produced from the correlation model is shown over here. In this example, the first two parameters, that is 00105460 and 031676953, are two different product IDs. 5 is the number of customers who have rated both of these products, and 0.18 is the correlation between the two products. So after computing the correlation between two products, we wrote a ranking model using insert-sort technique that sorts all the products correlated to the product according to the correlation factor obtained. Hence, the most highly correlated products are ranked first, and so forth. Also, the output thus produced from this model serves as a model for the collaborative filtering recommendation system. A sample output as generated from this ranking model is also shown over here in this slide. In this example, product 00071411076 is correlated to product 007154615 with a correlation value of 1.0. Similarly, 00600988899 is also correlated to the product 007154615 with a correlation value of 1.0, and so on. So the last implementation model for the system is the recommendation model, which recommends the most highly correlated products to the user on the basis of each of his purchased products. The sample shown in the slide over here is a direct output result as obtained from the system. In this output, for a customer who had purchased the book with product title The Color of Magic, the recommender system recommends books like Harry Potter and so on, which is all about magic. You may question that the purchased product title Color of Magic and the recommended product title The Color of Magic is same. But if you check the product IDs, the purchased product ID and the recommended product ID are different, which means that they could be the different versions of the same book or could have been published by different publishers. Hence, considering this example and many other visual observations of the output, what I would like to say here is that this recommender system works as expected.